you think you've seen this before, you might have. I had to fix an audio glitch at about 16 minutes, so I reposted it. I'm designing this in an awesome new CAD program called Plasticity. It's a powerful tool perfect for this job, and it's fun to use. Check my description for a link for a free trial, and also there is a discount code, Red Baron, that you can use for another full 10% off the purchase price. In this design, I'm going to cover some design rules that I will follow to make this thing print very cleanly on the 3D printer. As I mentioned, I'll also be using a filament called lightweight PLA. Now this is a foaming style filament that produces incredibly lightweight parts, but it introduces some additional design challenges that we need to plan for in the design of the model. So I'll address these aspects while working through this rocket. These rules also translate to the design of any flying lightweight PLA printed model. To start with, we need to find as accurate of a schematic image of our model as possible. A quick Google search landed some photos that I can use as a background image to sketch from. From here, I need to decide how big I want to make this rocket. Really, you could scale it to any size that you wanted, but since we will be 3D printing this, there will be some very close tolerances between how parts fit together. So we want to design it to the actual scale that we intend to print it out. Also, one of the design solutions to make this rocket not burn up is that I'm going to introduce a paper core down the center of the model. That one adds additional rigidity, and two, a buffer from the ejection charge heat that pushes the parachute out. Normal rockets that are made in this fashion use very nice, glossy, slick tubes, and you could use that too if you wanted, but I wanted something super easy and available and free.
Aircraft quality.
Now these will never be seen as they are on the inside of the rocket, so the scale needs to allow for the diameter of that tube all the way through the rocket, even where the model tapers down on top. Now next we need to design the holder for the rocket motor for first attempts at this rocket. Unlike the original model, I'm only going to use one engine for simplicity and kind of safety. And I'm going to try C-size Estes rocket motor first. And that motor has a specific dimension of 18 millimeters by 70 millimeters. Now this assembly will be bonded inside of those tubes, providing yet additional spacing to prevent heat buildup for damaging the rocket body. We'll get to that later, but dimensionally what I've arrived at for this model was 33.86 inches in length, and in the software you can design in any units you want, but it seems to be far simpler for 3D printing process to simply work in millimeters. So there's no confusion with slicers and scale values, and so that's what I'll do here. Therefore my conversion to millimeters makes this rocket 860 millimeters. Now here's how you scale your image to that value. First off, I'm going to be in object selection mode here, so that's keystroke 4. I can highlight my empty, and I'm going to come here to the bottom, and I'm going to hit the G command for move, and then very specifically the V command to set my axis right here. Now that I have that set, I'm going to drag this down to my red reference line, or origin point. We'll leave it there for now. Now I'm going to hit S for scale, and then F for freestyle, and come down here and select scale uniformly. Make sure that's on. Now I can touch my reference line, come up to my reference point that I wanted, which was right here at the bottom of the capsule. And now as I drag up, the image scales uniformly to my second reference line. Now right click. Now lastly, I want to make sure that this is centered on my Z axis here. So I'm going to highlight my image again, zoom in close to this image, say G again, and now V, and I'm going to pick right in the middle of that fin to represent the closest thing I can get to the center of this image. Then I can move it over, and you see as I come close to the green or my Z axis, if I hold my control key down, it will allow me to snap to it. And now that we're here, it's time to sketch. You'll see right here on the right hand side this group of tools. They are for sketching. And we can create lines, we can create curves, we can create circles. But funny thing in this software, they're all called curves. I explained why in another video here. Nevertheless, clearly, the one on top is the line tool, and that's the one we'll be using most. So I'm going to force myself to the view that had my sketch model. And you can see that my plane is showing right here up on the top. I'll use the sketch tool. By the way, shortcut is Shift-A, and I'll begin to sketch this all the way to the bottom. I'll worry about the separate sketch parts in just a little bit. I want to deal with the main body for now. Once I have this profile set, it's time to use the Revolve tool. On the lower right-hand side of the screen, 3 positions from the left, you'll see an icon for Revolve. Alternately, you can type the F key and then begin typing REV, and you'll find your command come up here. We're going to select Edge Selection Mode 2 on your keyboard so that we can grab the profile that we just drew. Now, when I touch the Revolve tool, I'm going to touch the center line in 2 places, vertically, and when I do, you'll see that I've created a body. Now, right-click, and you have what this program calls a sheet. That's what Plasticity calls a surface body. It's an infinitely thin shell. And even though I intend to print this in vase mode on a 3D printer, one that creates a single wall print, I actually want this to be a solid body, and I'll explain why this is best later in the video. To convert your sheet to a solid body, we need to close all sides and make it waterproof, so to speak. So in this case, I can simply do this by highlighting the sheet, touch on my sheet, and on the lower right icon here, I have an option to patch holes. Now I have a solid body. The reason that I want to work with solid bodies is really twofold, but the first reason is that we're about to add a good bit of surface detail to this body, and we're going to merge those bodies together. Since they are solids, I don't have to worry about cleaning up all sorts of interfering sheets and geometry inside the model. The second reason is how we will print it later. We're going to trick the slicer in using vase mode to think that it's only slicing the exterior when in fact it's going to create all the interior ribbing we want in a single pass with no retractions. I'm now going back to the sketch and I'm creating horizontal lines at key locations where we're going to add a torus actually and subtract that torus from the main body to create a circular indentation in the model. This is going to be important to do now because the ribbing that we make in a minute will have to be properly spaced inside of all of these components, otherwise it will just cut straight through it. So now that the lines are drawn, I'm simply going to use the Cut tool, highlight the model, and then highlight each of those lines, and those red marks are going to be where it slashes all the way through the model. Now eventually we'll put this all back together. What I'm doing here is actually highlighting the edges of each of these spots so that I have basically rings, and I'm going to use the Duplicate tool and then right click so that they duplicate. I also Boolean unioned all of the pieces back together before the next step. I have a ring around each of these pieces. I'm going to highlight it and I'm going to use the Pipe tool. So I set that up, and now we can use Boolean operation to subtract the pipes from the main body. I'm now going to create a rectangle all the way down the length of the rocket tube, and then I'm going to extrude it, and I'm hitting tab so that it extrudes equally on both sides. And then we're going to come down to the distance, and this is important, 0.18 on both of these values. And then when we right click on this, boom, we have a solid. What we're going to do now is use the Boolean operation to create an intersection, and we have a profile. Now with face mode selected, I'm going to select each of these edges all the way up the side, and you see how the rings cut out of it. And I don't want this to go all the way to the outside edge of the rocket body. We need to have a little relief. So we're going to bring this back in by 0.4 millimeters. Now I'm going to use the array tool. I'm going to array this profile, or the solid body, in a circular fashion from the center axis all the way around the model, and I want to put it in about 6 places. I now use a Boolean operation to union these all together, and then the very tip I don't need, so I'm going to create a rectangle here and Boolean subtract that. At this stage, we're going to turn the rocket back on, and we're going to Boolean subtract the interior from the main rocket body, so that we have these voids in the interior of the rocket body. Never mind all the additional detail on this. I later decided that it was better to do this process first, and then we'll get into the additional detail on the rails on the outside. Going back to my sketch now, I'm marking the tops and the bottoms of this structural ribbing so that we can use that in just one moment. Taking the edge profile line now, I will make sure that all of the horizontal lines intersect, and I'll simply use the trim tool to cut away so that I have the exact length of the segments that I want to use. Now I'm going to highlight each of those segments. When I have them highlighted, I'm going to use the pipe tool again and give it a section size of 0.7 millimeters. I'll go back to the sketch now, and I'm going to mark the location of these more pronounced triangular, looks like joiner bars. And we will do the same process again, not with the pipe tool, but with a rectangle. Well, actually what I'm going to use is the cube tool, and I'm going to tab to strike from center. And I made this 2 millimeters by 2 millimeters. And now I'm going to pull it down to the extents of the line segments that I had made. And then I am chamfering up and then deleting the top cap to make the point. I didn't want exactly a 45 degrees, so I'm actually scaling in the Z direction here to make the point a little bit longer. I'm sure there's other ways to do this. Then I'm simply going to cut it, and then I'll move into position where I want it. Do the same with the bottom, and then we'll Boolean union this all back together to create an entity exactly the length that I wanted. Now it's time to make duplicates of this at each of the segments. So you'll see me bringing it up here, and the segments are of different lengths. So we'll have to do the same thing here. We're going to, in this instance, grab all the faces and then just move with the G command, move it down. And now I'm going to rotate all of these bodies exactly 45 degrees on their axis. Then with the inside faces, I'm going to select them, and I'm going to arbitrarily move them to exaggerate them into the body of the craft. Now you can see we're finally at a point where we can array these around the body of the craft. Now the numbers are a little bit different for each of them. Some are 4, some are 8, and then the small ribbing is quite a bit more. Now let's isolate the smaller ribbing. So we're going to do that, and then I'm going to select all of it in edge mode and then start a fillet. And it will fillet all of them. And if you remember, the size of this fillet was 7.7 millimeters, and that just bullnosed or rounded over the tops of every last one of these. And now we can array these. So I'm going to select them all again. I'm going to hit F, search for array, and then type in a number of 40. And then we can Boolean union these all to the original body. And we have a clean, singular, solid body now. Here you're going to see me tracing out the actual rocket or the motor body and the fin. So I'm drawing a length at the bottom, and then I'm going to use the array tool to bring those all up so that they're even spacing. Now this one at the top had a little bit of a curvature on it, so I'm putting a half circle on it, and then you'll see me adding the stepping going down here, and it's a bit tedious, but then I go and trim it all out and create a single profile, then join it together. Now I make a duplication of it, bring it to the inside of the wall, and create a solid profile or a joined profile. So again, I'm going to find the midpoint of this, and we'll use that in a minute for revolving these profiles around an axis point. So I'm going to finish drawing out the shell and then the little fin area, and then we're going to use the revolve tool and flip it around that vertical axis we made. I'm also going to do this with the shroud on top. I'm going to create a circular body here, and I'm going to want to subtract it from the shroud. But I'll find out that the shroud is a sheet, not a solid. So what I'm going to do is go to the top of it, and I'm going to use the patch tool to put a curve on the top of this thing. Now I can, after I fix a little bit on the bottom, I can use a Boolean subtract feature right there to remove it. So doing a little cleanup here, and then you're going to see me just pull that cylinder up to make this part stronger. And then we're going to do some more Boolean subtraction. I'm going to make another cylinder here to replicate the size of the whole rocket body. And then I'm isolating those with a period key. I'm going to pull that up and then Boolean subtract from the shroud as well. That way I didn't have all of this geometry from those little ribbing inside of it. Here I'm just extending the top portion of it, and then I'm going to union it back together. So we're in good shape. Now it's time to make the fin. I'm going to create a rectangle just kind of as a plane to work from and decide what size I want, and then using a curve, outline a rough shape of my airfoil. Now I'm duplicating it to the back side, and I'm going to freestyle scale it so that it moves all the way to the top, and then we can do a loft. I'm lofting the bottom of this, and then when I join them I can patch the sides. And then now I'm going to extend that into the main shroud body, and then we're going to union it all together. And now we have a solid piece. And you see me using a circular array tool here to wrap these around the rocket body. Okay, obviously this is far too tall to print in one piece, so we're going to have to cut this up into sections. What I chose to do was I found certain areas of the model that I thought would work well. I have the lower unit here, this middle, this upper unit, the caps, well, I don't know what you would call this, the very top unit, and then the capsule itself. So I had to draw lines on these and just literally physically cut the model at those places. Let's go down to here. I'm going to hide this one for a moment. What you'll see is that I actually created this with a step in so that it can interlock with the model piece above. And that was simply a matter of me slicing the model where I wanted to slice in these two spaces. Then I duplicated this part. I hid one of them and then simply touch the outer edge and offset the face in, 0.65 millimeters. And then I could simply Boolean union it back to the original model. Then, when I turn on my upper stage piece, there would have been a line here for the other one that we had duplicated, and we're going to Boolean union those two together, and then we would simply Boolean subtract the lower stage from the upper stage. And when I do that, I get this nice interior lip here so that we can interlock these parts. Now, the hole in the center. You're going to want to measure the diameter of your towel holder or tube, whatever you choose to use, and simply run an extrusion straight through the middle of your rocket and then Boolean subtract to get that part done. Top tower. Well, this part right here looks like an upside down golf tee. That was simply a revolution, just like we did, of the main body. And then these seem fairly difficult, but they're really not. I'll show you right here. I'm going to draw a vertical axis, and then I'm going to draw a tapering curve. And now when I'm going to go into this view here, I'm going to do a radial array, touch the center of my axis, and I'm going to tell it 4. And now when I right click, I have these 4 points. But what I'm going to have to also do is, now that that is done, come up here and rotate them 45 degrees. Now I'm going to simply, in key areas like these cross support bars, I am going to draw horizontal axis, and using a cut key twice, now I have literally cut all of these. So it's a simple matter of snapping to the endpoints to create my horizontal pieces. And now if I do this at the bottom, now it's very simple to simply draw in your diagonal supports as you see fit to use them. Once you've drawn these all in, simply touch on one of your components and do the pipe tool. And I used a section size of 1 millimeter to draw these parts. Well, guys, if you're still with me, you guys are rock stars. This has been about 25 minutes. So we're going to stop here, and I will upload the next section of this video, and we're going to cover printing, we're going to cover assembling, and of course we'll cover flying. So like and subscribe if you haven't done so already. Certainly hit the bell notification, and if that doesn't work, just watch the next video here.